Welcome back. Today we're going to start with the distance formula. This is on page 642 in your book. The first problem on that page asks what the distance is between these 2 points. So if you think about a graph, -1, 3 is right here. 4, 3 is right here. So this distance is 1, 2, 3, 4, 5 spaces. We can figure that out by doing 4 minus -1. So if we subtract our x's, the x2 minus the x1, we'll get our distance. Again, if you remember, this is your x1, y1 because that's your first point, and your x2, y2 because that's your second point. So that is our distance between the points because the y's are the same. So we're going to step it up a slight notch here. This is not number 2, but this is just a random problem. So if you have the points 1, 1, and 4, 5, and you want to know the distance, we could plot them 1, 1, and then 4, 5. So this is a diagonal line. So in order to find the distance for a diagonal, we're going to drop our altitude, which is our height, and our base. So this is a 90-degree angle. This distance at the bottom is 1, 2, 3 spaces. This distance on the side is 1, 2, 3, 4 spaces. So to find the diagonal length, we could use the Pythagorean theorem. 3 squared plus 4 squared equals c squared. So 9 plus 16 gives us 25. And then to solve that, we would square root both sides. It is positive or negative. Negative doesn't make a whole heck of a lot of sense, so we'll just do the positive. So the distance formula is actually derived from the Pythagorean theorem. This 3 is figured out by doing the difference of the x's. So x2 minus x1. That's 4 minus 1. This 4 is figured out by doing the difference of the y's. And that would be our 5 minus 1. So my a squared is really x2 minus x1 squared. And my b squared, I'm going to change my, is really y2 minus y1 squared. And that equals c squared. So to find c, I square rooted both sides. So distance formula can be written as the square root of the difference of the x's squared plus the difference of the y's squared. It's really just the Pythagorean theorem. If we did the same problem with just this formula, we would have 4 minus 1 squared plus 5 minus 1 squared. That's 3 squared plus 4 squared, 9 plus 16. And then when you take the square root of your 25, you still get 5. Same exact thing as right there. So let's do one more problem like this. I'm going to give you 2 points. This time you don't really need to plot it. We'll call this 3, even though this is really no number 3 in your book. 1, 9 and 2, 5. So this is our x1, y1. This is our x2, y2. Our distance formula is the difference of your x's squared plus the difference of your y's squared. Whoops. all square rooted. So we can put in 2 minus 1 squared plus 5 minus 9 squared. So we have 1 squared plus negative 4 squared. So that's 1 plus 16. So the distance of this is the square root of 17. If you want to put 4.1, you can, but this is a better answer because there's no rounding error. All right. Next up, we're going to move into section 9.8. And a quick recap, to solve this, you would take the square root of both. So x would be positive or negative 3. This is another way to write it as a solution set. That's what these two brackets means, a set of numbers. We wrote it that way last time, I believe. Square root both of these for the next one, you're going to get positive or negative 11. Oops. Square root both sides, you're going to get positive or negative square root of 17. And for the last one, we actually need to solve this. And for the last one, we may want to look at it like this. So when we take the square root of both sides, we get x equals the positive or the negative r plus 15. So that's going to either be r plus 15, or if you put the negative through, negative r minus 15. So in this section, we're going to factor things by making equations a perfect square. So what would this number be so that I could have x plus 4 squared, because that is going to be my number right there. If you FOIL this out, you get x squared plus 8x plus 16. So that means that this would be 16, and this would be 4x. So this is the mindset you need to be in for this section. So next up, we have x squared plus 6x. So basically, if I have a 6x, these need to be the same number, so they're both going to be 3. Therefore, this last term would need to be 9. So I would need to add a 9, and now that's factorable with perfect squares. X squared plus 2x equals 0. And we're going to think about this a little bit different way. If I have a x squared here, if 2x is going to be the same exact number, that means that each of these are going to have to be a 1x. So I'm thinking I need x plus 1 squared, which means this last square is going to be a 1, because this would FOIL out to x squared plus 2x plus 1. So we're going to add a 1 to both sides, because we have to keep the balance. So we have x plus 1 squared equals 1. It was initially equal to 0. And then we're going to solve by square rooting both sides. So x plus 1 is going to equal positive or negative 1. So let's just write that out as two completely separate problems. And then we would subtract 1, so our one answer is 0. When we subtract 1, our other answer is negative 2. That makes a lot of sense, because this initial problem up here, in the old method that we used, we could factor that to x times x plus 2. So we do know that our solutions are 0 and negative 2. All right, so we're going to write the equation. Whatever this number is, we need to take half of it because in our box, this is our x squared, and then these two sections are equal and they add up to this. So it's half of b. Half of b is written that way, or as it is down at the bottom where I circled. Once you find that, you know that your factored form is the x squared plus the half of bx, and then you can FOIL it out. Once you have that, you know that your factored form is the x plus the b over 2 squared, because that FOILs into x squared plus b over 2x plus another b over 2x plus b squared over 4. So this half b and half b is a whole b. So we're going to get this last term by taking half of b and squaring it. So let's try a couple with the completing the square method. So this means I'm going to have x plus 3 squared, because that number is always half of b. So I'm going to need to add 9 to both sides, because I need to square that number. Half of b squared is what this is, the 9. So this factors into x plus 3 squared equaling 9. You're going to square root both sides. X plus 3 equals positive or negative 3. Therefore, x, if you subtract the 3 from positive 3, it'll be 0. If you subtract the 3 from negative 3, it'll be negative 6. So those are your two solutions. Okay. This next one, I'm going to move the 7 over just so I don't have to worry about it. And then I'm going to figure out what I need to add to both sides. So my x squared plus 8x, I know that x plus 4, because that number is always half of b, is going to be my factored form for completing the square. 4 squared is 16. So I need to add 16 to both sides, and I get that by doing 4 squared. So on the left here, I have my x plus 4, and on the right, I have 9. Then you're going to square root both sides. So you have x plus 4 equals positive or negative 3. And when you subtract 4 from positive 3, you get negative 1. When you subtract 4 from negative 3, you get negative 7. In C, we've got a 16. So I know that my factored is half of 16, which is 8. That means I have to add a 64, because that's what 8 squared is, to both sides. So I have x plus 8 squared equals 64 minus 15, which is 49. We're going to square root both sides. So x plus 8 equals positive or negative 7. When you subtract 8, 7 minus 8 is negative 1, and negative 7 minus 8 is negative 15. Okay, move the 6 away so it does not affect anything. If I have a 4x, that means my factored form is going to be x minus 2 squared. This minus right here means the whole thing is minus, but we're still going to add negative 2 squared to each side, which is 4. So I have x minus 2 squared equals 10. This time 10 is not a perfect square root, so when you square root both sides, you're going to get x minus 2 equals plus or minus root 10. Whoa. So you're going to add the 2 over, so x equals 2 plus or minus square root of 10. That's the 2 solutions. That's telling you you have 2 plus the square root of 10, and you also have 2 minus the square root of 10. You could find the decimal in your calculator, but the decimal is error, rounding error, so you can just leave it like that. And the last one, we have x squared plus 8x equaling negative 18. And we want to complete the square. That half of 8 is 4. So we know that it's going to be x plus 4 squared. And that means we need to add a 16 to both sides. So we have x plus 4 squared equaling negative 2. Now, when you go to take the square root, you can't take the square root of a negative. So this is an imaginary number, which we're going to get to later. So there is no solution here. And you are done because your squared part is equaling a negative. And last but not least, if you have a number in front of the x squared, you need to make that a 1. So your very first step would be to divide by 3 to get rid of that. So this is going to simplify into x squared minus 10/3 x equaling negative 1. Now, half of 10/3, so 10/3, half of it is 10/6, because we were doing half of b. That simplifies to 5/3. So our factored form is going to be x minus 5/3 squared. Now, 5/3 squared, that c value is 25 over 9. So that's what we have to add to both sides of the equation here. So my factored form is x minus 5/3. And on the right here, negative 1 is the same exact thing as negative 9 over 9. And negative 9 plus 25 is 16. So when you square root both sides, you get x minus 5/3 equals plus or minus the square root of 16 is 4. The square root of 9 is 3. So you're going to solve this by adding your 5/3. I'll just kind of write it separate here. So our 2 solutions are 9/3, which is 3, and 1/3. So in this one, we're going to divide everything by negative 5. So we get x squared plus 2 negatives make a positive right there. So I'm just going to write that as 19/5. And I know I'm going to need to add something. And way over here is going to be my 4/5. And again, that's positive because there's 2 negatives. Okay, so half of 19/5 is 19 over 10. And that's really not reducible. So we're going to square both of these. And 19 squared is 361. So we're going to be adding 361 over 100 to both sides. So on the left, I know my factored form is that 19 over 10. So I'm just going to write x plus 19 over 10 squared. And that's going to equal 400. Oops, I got to make my common denominator first. So we're going to multiply both of those by 20. So I have 80 over 100. So that adds up to 441 over 100. So you have x plus 19 over 10 equals plus or minus 441 out of 100. Ironically, that's a perfect square. Oh, plus or minus another perfect square root, 21 over 10. So when you subtract your 19 over 10, your two solutions are negative 19 plus 21 over 10, which is 2/10, which is 1/5, or negative 19 minus 21 over 10, which is negative 40 over 10, which is negative 4. And the last problem, when you divide everything by negative 3, you get x squared minus 4x plus 5. And then you're going to move the 5 over. This one doesn't look too horrible because half of 4 is 2. So this is going to be x minus 2 squared. And then when you figure out your c value, it's 4. There's a problem right here. That adds to give a negative. You can't take the square root of a negative. So this is, again, no solution. Hopefully you've enjoyed completing the square. It's definitely a different method of solving. And have a great evening.